is MLKit? Well, before we decided to work on MLKit, we talked to a lot of developers, and we asked them how they were using ML in their apps. And they told us it was actually quite hard to use. You need to have machine learning expertise to build models. You need to have a lot of training data. You need to collect that data. So it wasn't as easy. So as a team, we made it a singular goal to make ML easy to use for developers. We looked around Google and saw that there were a lot of powerful ML models being developed as part of Google research. And so the next step was actually rather obvious. Like, why not take these models, wrap them in a nice, easy-to-use SDK, and provide them to you? So that is how MLKit was born. MLKit is Google's machine learning SDK for mobile. It is built on top of the TensorFlow Lite runtime and is available both for Android and iOS. That makes it easier for you because you don't need to integrate an ML solution twice, one time on Android and one time on iOS. Since we started MLKit last year, exactly a year ago, we have grown the set of APIs. We started off with APIs for vision-based applications. Examples are text recognition, barcode scanning, and image labeling. Earlier this year, we extended that to natural language processing with APIs like language identification, which identifies the language of a string. And also Smart Reply. Smart Reply gives you suggested responses as part of a text conversation. We also have model serving. This allows you to serve a custom model from the cloud and keep your app small, and also allows you to do experimentation. So you can do A/B testing of 2 versions of a model in the field with real clients. So how have we been doing? Well, we saw a lot of strong interest from developers. More and more apps each day use MLKit to create powerful new features in their apps. And it's not just apps. We also see strong engagement from actual users that use these features. And as we are extending MLKit with more APIs, we see this engagement accelerating. And this is not just on Android. We're really happy to see that about a quarter of the apps using MLKit are running on iPhones. Here's a sample of companies that use MLKit. And as you see, there's a big diversity here. We have very small mobile-first companies, as well as larger, well-established retailers that make use of our APIs. So over the last year, we learned a lot. Not just by building MLKit, but also by talking to developers like you that give us feedback. And in that feedback, we saw 3 clear themes. The first theme was, you really like the base APIs, but please give us more. The second theme was that although the base APIs are nice, they help me directly solve a problem, building a rich and intuitive user experience around it is rather tricky. And lastly, we realized that the base APIs help you with certain common challenges. But a lot of times you need to solve use cases in your app that are more niche, that are more tailored towards your app. And for that, it's still quite hard to build custom models. Since we built MLKit for you, we listened and we built some cool stuff. And we're really excited to present that to you today in this session. So let's get started. We're adding 2 APIs to MLKit. Let's talk a little bit about Google Translate. Google Translate is the world's #1 digital translation solution. It is used by more than 1 billion users each month. And all those users together translate about 85 billion sentences each day. And of these users, more than half are running on mobile devices. Now, mobile machine learning has not been applied to language translation for a long time. We only introduced neural machine translation models at the end of 2016. But this led to a huge boost in translation quality. And this was also available to you. We provided the Google Cloud Translate API that allows you to integrate translation into your apps. Now, we did realize that users are not always online. That's why the Google Translate app introduced offline translation. And it took these NMT models that were running in the cloud and optimized them for use on mobile. However, these models were not available to developers. And that's what we want to change today, is by offering offline translation as part of MLKit. So that is the first API, on-device translation. It translates between 59 languages and uses the exact same models that we use in the Google Translate app for offline mode. They fully run on-device, and are available to you at no cost. Now, to show you how this works in a real app, I would like to invite Shiyu on the stage.
Thanks, Christian. I'm Shiyu. I'm a tech lead for MLKit. So to demonstrate the translate feature to you, we thought about it for a while, saying how to do it. Since I do not want to type on the stage, and I only know about 2 languages. So instead of do the manually language input, why we cannot using some existing MLKit features to helping us? So we built this demo app. It's using the camera streams as input, and then it will translate. Please come back to the slides first. And it's using camera stream as inputs, and then we're using the text recognition to recognize the text in the images. And then we're using the language identification to identify which language it is. And then finally, we're using translate to translate that language into English. So let's switch back to the demo. Let's take a look. So this is the demo app, and then we want to scan some text on the paper. And this one, I do not know what it is. I don't know what language it is. I do not know what that means. And it's translated to English as, how are you doing today? I'm doing good, thank you. So let's try another one. So the next one I actually know is like from my friend Christiaan, who is from Holland. It's a Dutch. And it's translated to English as, when does the train go to Amsterdam? OK, for this question, I probably need to check it out. So since all the 3 features are all running on the device, so it's super fast. So if we're moving from these 2 lines code, you can see how fast the translation and also the text recognition and identification happens. Thank you. Please switch back to the slide. Thank you. So how does it work? Let's take a look. So Christiaan mentioned in a couple of years, the model get improved a lot. Before, we are using the phrase-based machine translation. That model can translate phrase by phrase. So every phrase may make sense, but the whole sentences may not. Then we switch to a neural machine translation model, which will translate the whole sentences with one piece. And the whole sentence will make more sense. And the MLKit model in the translate are all using the neural machine translation models. Let's look into more deep for these models. Translation is based on language packs. And each language pack has 25 to 35 megabytes. So it doesn't make sense to bundle all these language packs into your app. That will be so big. To do that, we're providing a downloading API for you so that you can download in the needed language packs as you go. So that it can help you to shrink your app size. Further, we have like 59 languages. So totally, the language pairs will be almost 3,000. To reducing the number of language pairs, we're using English as the intermediate language. So here's an example. On the top is my friend Christiaan told me, it's like, at 10 was heroic. It means the food was delicious in English. So it's translated to English first. And then it's translated to Chinese as 食物很好吃. So that is how it works. OK, let's look into some code sample. To using translation, we're starting with an option. So the option will set up where the source language and where the target language. With this option, we'll construct the translator. just by passing the option. With the translator, before we do the real translation, we will download the model first. So the API is download the model if needed. So that will download the model for you and then has a callback. Once it's successfully, it will using the translate. You can use the translate to translate the text to the target language. And then that is the code for the translate. And for that, I will hand it back to Christiaan.
Thanks, Shiyu. OK, let's talk about the second base API that we're launching. This is the object detection and tracking API. Let's walk you through a scenario. I recently visited Shiyu's house, and it looks a little bit like this. He really likes bright colors. And I saw a couple of items in his living room that I actually quite like and may fit nicely in my own living room. And in the afternoon, I happened to be visiting my favorite Swedish retailer, and I would like to see if they have similar items available and if they are in stock. Now, I don't really want to bring up a website or open an app and then browse through a catalog. So how can we use ML to make this a bit more magical? Now, funny enough, IKEA had the same question, so we decided to partner with them. So let's show you what we came up with. Please cut to the demo. So we're going to launch the IKEA app, and then we're going to see the live camera view, and it allows us to scan objects. So let's try a first object, this lamp, for example. As you can see, we find the lamp and several other lamps that look like it. OK, let's try another object. This clock. We scan the clock. We find the clock and other items that look fairly similar. Please switch back to the slides.
OK, let's talk about how it works.
Please switch back to the slides.
Yep, how does it work? So this is the end-to-end working flow of the demo you just saw. It contains two parts, the on-device part and the cloud part. For the on-device part, we're using camera stream as the input. And the camera images will go into the ML kit ODT. ODT means object detection and tracking. And the ODT will try to find the objects inside these images. And then optionally, they will also do a cost classification to classify this object into some categories. And once the user using the camera to moving around to find the different objects, and then they find, OK, this is the object I have interested. Then we'll crop that image to have like a smaller image only contains that object. With that object image, we'll send it back to the cloud. And in the cloud, we do the cloud visual search, which basically do the image matching. It will match the uploaded image to the product's image, and finding the similar products, and then sending back to the device. And for the cloud visual search, for this demo, we're using Google Cloud Vision product search, but it's also working with you can also using other third-party solutions. OK, so let's take a deeper look of the on-device part provided by ODT. So we're starting these features with two models. The first model is a localizer. The second is called a classifier. The localizer is to localize to finding objects inside the images, and the classifier to do the optional classification set. And then we run these two models into the live stream. The results doesn't looking good. You can feel like the image is a little bit choppy, and the bounding box is a little bit delayed. The reason is it's too slow. It's totally take 100 milliseconds to processing one image, so it can only process 10 images per second. It's not good. Then we think, do we really need to processing in every image with these two models? Then we're introducing a new model called the tracker. The good thing about tracker is it's running pretty fast. It can run in less than 10 milliseconds on a typical Android device. And once the localizer finding the object, it will hand over that object to the tracker, so the tracker will take care. So we only need to run the localizer and the classifier once for new object. Here's how it looks like. So with the tracker, we can process 30 frames per second. so it's real time. And this real time is not only in high-end device, but also in low-end device. For example, like Nexus 5. So this making the feature is much more useful. Okay, let's also took in some code. So similar to the translator, we also set up starting with the option first. And for the ODT, the ODT pipeline is highly configurable. Right now, you can using streaming mode, single image mode. You want to enable classification, disable classification, or you want to using prominent objects or multiple objects. For details, you can check to the dev doc. With this option, we will creating the detector instance. It's simply just sending the option to construct it. Then we want to get the input image. The input image is using Firebase vision image. So Firebase vision image can be constructed by different formats. So for here, we're using bitmap. It actually can also taking like the camera by the buffer, by the array. Once we have the image, we send it to the detector to process. And it will return a list of detected objects. For every detected object, it will first providing a bounding box to see the bounding box you see in the demo. And if you are enable classification, it also will provide you a category. And if you are streaming mode, we also provided the tracking ID to make sure like this object will be the same object in the stream. Okay? So that is the code for ODT. And one more thing, we're also working with Adidas to demonstrate the power of ODT. So in the next demo, we want to show you is like Adidas in-store experiences with Adidas app. And then for that, for example, like imagine we're actually inside the Adidas store, and then we're finding a shoes I really like, and I want to try it out. I want to see whether it has the size, my size, or whether it's available on the store. So for that, let's cut over to the demo. Yep, let's restart it. Let's start Adidas app. Okay, so I think we can use in the normal search.
Sorry.
Okay, so
1 second.
let's try it again. I think there are some internet issues. Okay, here we go. So there is a product scan. Let's scan the product. Okay, so this is the shoes I'm talking about. I like the shoes. The reason is it actually has ML kit patterns on it. And actually the name is called the ML kit. So I really want to try it out. So I want to see whether it has my size. My shoe size is 9. See whether it's available. Let's try. Oh, great. It has 9. I want to try it out since I'm in the store. And then, OK, so I have that size. And then please up to me. Cool, thank you. Yep, thank you. So yeah, I will also try my shoes on, and then I will hand back to Christiaan. Thank you.
Thanks to you. OK, let's talk a little bit about UX. As we were developing the object detection and tracking API, we realized that just providing an API is not sufficient. Actually, giving users a good experience with live visual search is pretty tricky. And so we reached out to the material design team. And as we were talking with them, we realized that we had fairly similar goals. Their goal is to democratize digital design, and ours is kind of to democratize machine learning. So we thought, why not work together to help developers build great solutions that make use of ML? As part of this collaboration, we have launched some extensions to the material design guidelines. These guidelines can be found on the material.io website. And there we provide guidance on how to use material design components to build experiences like visual search or barcode scanning. We assist you with building a flow that helps you tackle challenges that only come up when you integrate ML. And we also help you to do theming to use color, shape, and typography to ensure that your brand identity is not lost, is represented in the app, but you still get a great user experience. A second outcome of this collaboration is that we actually built a couple of showcase apps. These are real, polished, end-to-end experiences that have been tested with actual users. And what is great is that we're making these apps available on GitHub so that you can also integrate this in your app very quickly. So with this experience, some of our partners could integrate this whole experience in a day or less. And it really sped up development. And it saved them many months of design and user testing. And with the launch today, this is something you can do as well. OK, the last topic that we want to discuss today is about custom models. And how we're going to make it easier to build custom models. I want to invite Anne and Sonakshi on stage.
Thanks. Thanks, Christian. Hey, everyone. I'm Sonakshi, and I'm a designer on the MLKit team. So when we got started with MLKit, we'd identified two kinds of developers. On one end, you can see someone who needs a more turnkey kind of solution, something more common. They don't know too much ML. They don't have access to too much data. And on the other end, there are ML experts. They have lots of data. They know what they're doing. They might come in to host their custom TensorFlow models on MLKit. And we thought there were these two kinds of developer, and that was it. Well, we identified another kind of developer. Someone like me, someone who needs a more common solution, has access to some data, and knows some ML, maybe took a few online courses or just studied some courses in college. And today, I want to share with you a really serious problem that I want to solve. I want to identify dog breeds. Well, I find dogs really cute, and there's so many amazing dogs at Google, and one such amazing dog is Unni, and that's Christian's dog, actually. So today, if I want to know what breed Unni is, I might use the on-device image labeling API. Let's see what that tells us. Well, that just says that Unni is a dog, but I guess all of us already knew that. So then how do I identify dog breeds?
Well, that's a great question, Sonakshi, and one a lot of our developers have been asking us. So we came up with a solution for you. Hi, everybody. I'm Anne. I'm a back-end developer on the Firebase MLKit team. We came up with a way of incorporating AutoML Vision Edge into the Firebase solution. So you can take your own data set. You can put that into MLKit. We'll train the model, and we'll export for you a TF Lite model. And then that has an optimized solution that you can use and run on device. Why do you want to run it on a mobile device? Well, there's lots of reasons. We're going to talk about a couple of them today. Latency being the first. It's faster. There's no back and forth talking to the network, waiting for results. And that means that you get the ability to run on device in real time. You can use your video camera. You can use real-time processing to get a better experience for your users. Also, user data. You can do it all on your device. You don't have to upload that image, send it across the data. You can do everything right there. So how does it work? We'll switch to the demo, please. So brand new, inside of Firebase, the MLKit, you've got the new AutoML tab. We're going to click on that. You get the ability to create your new data set. So once it finishes loading, we're going to click on the Create Dataset button. And we're going to give our data set a name, dog breeds. We only want to do single dog breed classification, so we're going to click single label, and then we're going to create our data set. You have a lot of different ways of uploading your images. All the standard ones are usually supported. We recommend that if you have a big data set, you put it in a zip file with the proper folder structure. You'll get the labels automatically applied as you upload your images. So let's browse for a file and drop it in. We've got our data set. And it's going to start uploading our images. Then it's going to do a bit of validation. And then it's going to import our images. This will take a while. We've got 20,000 images in this zip folder. So we'll actually send you an email when we're done. So I've done that today. You guys don't want to wait an hour. So let's switch to the next tab where we have our images available. As you can see, we've got our Label Images tab. We've got a lot of labels down the side, but you'll see a little warning, that little yellow sign. And it tells us that we recommend that you have 100 images. So I noticed that. I uploaded a few extra images. So let's switch to the Unlabeled tab, and we'll select a few extra ones so that we can get rid of that warning. It's really easy to label your images. You click on them, you hit the Manage Label button, and you can type in the label you want. In this case, it's the miniature Leonberger, and so we'll apply that label. Very quickly, that warning is gone, and we're able to train our model. So inside the training model, we're going to give it a better name. And then you have a couple of options for your latency and package size. So depending on the type of users that you have, you're going to make the appropriate decision. If you have a lot of clients that use the smaller devices without a lot of memory, you'll probably want to pick a smaller package size, and you'll choose low latency. Might take a little longer, but you've got a smaller data set. Smaller size. If, however, your model needs a lot of accuracy, you're going to pick that higher accuracy model, and it's going to be bigger. For most people, the general purpose solution is appropriate. So then your final option is to the training time. So we normally recommend 2 to 3 hours for every 1,000 images, so we're going to pick 8 hours here. The good news is that once your model is optimized, we stop training it, and we don't charge you for any extra time. So we'll train the model, and again, we just told this model that it could take 8 hours. You'll get an email when it's done. So we're going to switch to a tab where I've already trained this model for you. So you can see here the training is complete. We're going to go inside. And you'll see that we actually only took 5 hours. So we weren't charged for the full 8, only for 5 hours for training. If you look at the evaluation details, you have a threshold. This threshold is a number that you, as the developer, will set in your code. It will tell your users, tell the model what accuracy, what confidence level you want for your results. So if we moved all the way up to 0.9, it would only give you back a label if it was confident with a 90% confidency. Now, that might be important to you in some cases, it might not in others. For example, in our dog breeds, what if we've got one that's coming back at, it's 48% this and 54% that? Would we want no label? Or do we want to lower that threshold down to 25%, and you just give me the best guess, which would be the one with a 48% confidence? Scrolling down a little further, we have our confusion matrix. And this identifies areas in your model that have the potential for confusion. So here we've got the Siberian Husky and the Eskimo dog being identified at the top. Now, as a human, I get these confused all the time, so I'm not too surprised that the model has some problems with that. You, as a developer, have a couple of choices here. You can add more images and retrain, hoping the model gets more accurate. Maybe you want to merge them into a Husky-Eskimo hybrid. It depends on what's important to you. You might also find that if you look through those images, some of them are actually mislabeled. I actually had that when I trained a flower set. So this confusion matrix will give you some information that's making your model more efficient. And we're going to go back up to the top. And we did this because we wanted to find out what breed Unni is. So let's take a picture of Unni and test our model. So Unni is a staffy. And I asked Christiaan, and Unni is, in fact, about a third staffy, so fairly accurate guess here. Now that's great. We've got our model. It's really easy to use this. Just like all of the other APIs that we give for you, you just put your model into your app. So we actually have a demo app. If we could switch to the demo app, please. To the phone, thank you. So the other day, Christiaan was given a Christiaan and Unni look-alike. So let's scan across and see what happens. It's not quite Christiaan, but close enough. Is this Unni? Is this Unni?
Oh, OK.
There it is. We had it for a second. Siberian Husky's pretty close, too.
Oh. That's OK.
Oh, it's OK. Yeah. Back to the slides, please. As you can see, we were able to use our model. Oh, my goodness, I skipped a whole section. So normally what you would have had to do to get to this stage was build a, traditionally, you would have had to build your model out by training your data, developing your model, training and tuning, deploying, and then giving it to your developer to predict. This would have involved a lot of people traditionally. And I've skipped ahead, and I apologize for that. So now you get to do it all yourself. So you saw the model. How does it compare to what's out there? Those handcrafted models that had experts, it's 1.8 times faster. How did we do that? We incorporated speed into our search algorithms. And that meant that the models are faster and just as accurate. The beta is now available. You can start at no cost and pay as you go. For most developers, that free trial is enough to generate a model that you can deploy and use in your app and give your customers a good experience.
Thanks, Anne. So as you saw, Anne had a really comprehensive data set of dogs. It had around 20,000 images. But if you've done machine learning in the past or tried, like I have, you know how difficult it is to just start by preparing your training data. And getting a comprehensive data set can be really tough. And that's why we have Custom Image Classifier. It's a sample app that we've made to collect, label, train, and test all from within one app. And what's even more amazing is that it's open source, and you can find it on GitHub at this link. So let's just get into a demo, and I'm going to show you a flag classification sample app. So, sorry, if we could go back to the demo, switch to the phone. Oh. Cool. So let me just tell you what I actually want to do. I want to set up a use case to classify flags from different countries. So if we go into the app and open the datasets page, we can actually go and create a dataset. And let's create a dataset called flags and describe it as flags of the world. As Anne is typing that out, you can see on the screen that you can actually share your dataset if you wanted to and make it public to share it with other people. We really encourage collaboration through this app. And as your dataset is created, the next step is to create labels for flags from different countries. And this will be faster in real life, trust me. Demos sometimes do weird things. But as that's happening, you will be able to see your dataset with labels on it. And in those labels, let's just switch to the World Flags dataset, where you can see these labels that we've already created for different countries. So you could create a new label, let's say, for Canada. I'm not sure if we already have that, but let's try it out. And you can see Anne making this new label, saving it, and adding more images to it. So Anne is from Canada, so she has a Canadian flag with her, and she's going to just take images of this flag. what's really cool is that you can actually even take a video and it'll break it down into images for you. And that's really important because you can take images from different angles, and that helps when your model is identifying images. Let's go back, and you might be able to see that you need at least 100 images for improved accuracy. But for now, we have at least 10, so we can begin training. And we've already trained this model for you, but if we had to go in and train this model, again, we would click Train Model and decide how many hours we want to train it for. Like Anne said previously, the recommendation is 2 to 3 hours for every 1,000 images. We're not going to do the training now, because that's going to take a long time. But let's go back and actually try to see if this model really works. So Anne has a flag from the country I'm from, but if some of you in the audience know it, don't say it out yet. Let's see if our model can recognize it. Let's take a picture, and it's trying. And it knows that it's India with a 0.57 accuracy. Thanks, Anne, for that demo. And if you all are as excited as we are when we created this product, please do come stop by the ML AI Sandbox and check it out for yourself. Can we switch back to the slides, please? And now I'm going to hand it over to Christiaan to take us home.
Thank you, Anne and Sonakshi. OK, after a bit of a whirlwind tour, let's do a quick recap. So we reiterated what MLKit is, and we showed a bit on what our adoption was. And we talked a bit about the APIs that we already had. But then we walked you through the new features that we've been adding at I/O this year. We added 2 new base APIs, which are object detection and tracking, and on-device translation. We talked a bit about material design that has extended the guidelines to include ML. And we also brought up the Showcase app that now allows you to quickly integrate these rich experiences into your app. And lastly, we talked about AutoML Vision Edge to make it easier for you to build your own custom image classification model. And then we also talked about how to make it easier to collect data with a custom image classifier. Now, the great thing is that this is available today for you to use and use in your apps. Please visit us on g.co/MLKit to learn more.